All right, we got another SUVOT problem, right? So we're going from RPMs. Obviously, we got to turn the RPMs into radians per second. And then at the end, we're going to do how many rotations it goes through, okay? So let's just set that guy up. Okay, so I think the first thing to do is to turn those velocities into radians per second. So 680, and that's rev per minute, right? If I multiply by 2 pi, I'll have radians per minute. If I divide by 60, I'll have radians per second. So let's do that. 680 times 2 times pi divided by 60. I'm going to store that in U because that's my initial velocity. 71.209. That's radians per second. And then 1540, same thing. Times 2 pi over 60. I'm going to store that in V just for kicks. 1540, and that is 161.268. Okay, let's see. And now we're all set. Now we can SUVOT, right? Right. Our acceleration is 1.8 radians per second squared, right? Our initial velocity is 71.209 radians per second. Our final is 161.268 radians per second. And I guess we want to find S. And when we get S, it will be in radians. And we'll have to divide by 2 pi to get the answer in rotations, I guess, right? Okay, so let's see. I think we want to use no T, right? So we're going to use V squared, U squared plus 2AS. And then S is V squared minus U squared over 2A. Right, so that is 161.268 squared minus 71.209 squared divided by 2 times 1.8. Okay, so I'm going to go, I've stored that, so I'm going to go parentheses alpha V squared minus alpha U squared, because I've stored those values. I don't need to type them in. Divided by 2 divided by 1.8. And I get S is 5815.75, and that is radians, right? So then the question is, how many rotations is that, right? So if you divide by 2 pi, now be very careful when you divide by 2 pi, put it in parentheses. Okay, so divided by parenthesis 2 times pi. Otherwise, it'll divide by 2 multiplied by pi. I'm getting 925.6. And that's rotations, okay? Now, as far as doing this in RPM land, the only catch is, do you know how to convert radians per second into revolutions per minute per minute? I do believe there's a factor of something like 3,600 there, okay? Just because, anyway, it gets complicated. So anytime you get you have to deal with radians per second and RPM, it's better to just do it in radians per second, even though there's an answer in rotations that we could use, but we're not gonna. All right, good enough.